Okay, let us see. This is the seventh chapter, confidentiality using symmetric encryption. So in this chapter, we will discuss how you can provide confidentiality using the symmetric encryption concept. So means confidentiality in the sense of providing secrecy to your message. So in this chapter, we will mainly discuss on the various vulnerabilities in your organization. So various places where there is a chance of having an attack. So you will discuss about so what are the places in our organization where there is a chance of having an attack. Usually, so you have to decide where you have to place encryption. So the searching for vulnerabilities in the sense you are looking out for where you have to place the encryption algorithm. You have to check because you have to place the encryption algorithm wherever you need it, wherever there is a vulnerability of having an attack. So usually you are having a vulnerability to your workstation when it is connected to the network. So when your workstation is connected to your network, the attackers can try to pass to your network, to your computer. And in the same way, when the server is connected to the network also, the attackers tries to access the server. And there is a place called wiring closet, so where all the wirings are connection. It is a wiring room, so all the LAN connection wires are placed here. If the attacker tries to tap the wires, so he can pass from the wires to your network. And there is also one vulnerability, satellite links and the radio satellite links. So you need to place encryption on devices, security devices there also. So like this you have to check where there is a vulnerability of having an attack. So and place the encryption algorithm in those places. So basically we are having two approaches in placing the encryption algorithms. So there are link encryption and end-to-end encryption. So link encryption is an encryption which you have to place for every link in a network connection. Whenever the data is being transferring from one router to another router or one, so in network you are having so many packet switching networks. So when one router is connected to another router, it is called a packet switching network. So there are many packet switching networks in a network for connecting various networks. So the link encryption is placed between at each and every link in a network. So at each and every packet switching network, you have to place link encryption, and you have to place this link encryption like a pair of keys. So for each and every link, you need to use a pair of keys, which is shared by both the packet switching networks. So and end-to-end encryption, you have to provide end-to-end encryption at the source workstation and at the destination workstation. You need to place only at these two places only. But whereas link encryption you have to place at each and every switching packet switching network and at each and every intermediate workstations. So at each and every place your data is passing, you have to place your link encryption. So you can better understand if you see the diagram. So if you see in this diagram, these two workstations are trying to access the server. So they are passing data to this server. So the end-to-end encryption is done. So it is shown in black color, solid black color. So end-to-end encryption is placed here, one and at the server. So these both will share the one secret key and data is passed. But whereas for the same data to transfer through network, a link encryption, various number of link encryptions are placed. See, for this workstation and for this first packet switching network, there is one link. So for this link, they use one pair of key. So from transferring data to this from this workstation to this packet switching network, they use one pair of key, and from this packet switching network to this packet switching network, they use another link. So another pair of key is used, and from this packet switching network to this packet switching network, you have to use another link, and you have to use a separate pair of key, and from this you have to communicate to the server, and for this also you need to use one link encryption and a separate key is used. The same way, so in the sense we have to observe that a link encryption is placed at each and every switching network, but whereas end-to-end encryption is placed only at the source device and the destination device. So you can better understand. So if you go into the details of the end-to-end encryption, when using end-to-end encryption, you must leave headers in clear, so network can correctly route information. So you can see when you are doing an end-to-end encryption, for transferring data to the network, you have to encrypt only the original data. So for usually the data is divided into packets. So for each and every packet, you are having a packet address and at the same time the original data. Okay, so these packet switching networks will identify your packet based on the address of the packet. So if you encrypt that address also, so it can't identify and it can't pass it through the network. So you need to only protect your data only. You need to close your data. You have to encrypt only your data, not the packet header. So that's the reason why packet headers are clear. But when you are passing the data, when you are sending the data without closing your packet header, the attackers who are observing the network can observe your traffic flow. So from which computer, from which route your packet is transferring, that information. Even the attackers cannot identify the original text, they can identify so from which route your packet is transmitting, and from whom and to whom it is sending, and what is the length of the packet, everything they can observe. So that concept is called traffic analysis. So they can do traffic analysis if you do only end-to-end encryption. But if you also place the link encryption, what the link encryption will do is it will also close your packet header. It will also close your packet header, and that is decrypted at each and every packet switching network. So the packet header is decrypted here and once again encrypted when it is sending to other network. So this encryption and decryption is done automatically. The user doesn't do that. It will be done by the virtual private packet switching networks itself. So it is automatically done. So in the same way, this network, this packet switching network will decrypt the header and encrypt when it is passing to another packet switching network. So in this way, if you place link encryption, your packets are also be saved. Your packet headers are also be saved, and you can save from traffic analysis also. So if you place only that link encryption, you can provide a traffic analysis. You can control traffic analysis. If you place only end-to-end encryption, you can only protect your data, not the traffic analysis. So the concern is you have to use the combination of both. So if you use both the link encryption and end-to-end encryption, then you can provide both the confidentiality to your data, and you can also protect your data from traffic analysis. So that is about so if you see, ideally what you have to do is end-to-end protects data contents overall over entire path and provides authentication. But link protects traffic flow from monitoring. Okay, this is what is happening. So if you see the OSI reference model, so you are having 7 layers in OSI reference layer. This link encryption is placed at 1 and 2 layers. You have to place link encryption at 1 and 2 layers, and end-to-end encryption at layer 3, 4. For layer 3, 4 and 6, 7, you have to provide end-to-end encryption. And you also observe that as you are moving your data, as you are going to the higher levels, higher layers, the information encrypted is very smaller. In lower layers you have to encrypt much data, but whereas in higher layers you have to encrypt very less data, but the security becomes even tight. So that you can see in another diagram. See here. So here in the TCP level, this is on links. So initially you need to provide encryption to network header, IP header, TCP IP header and data. So you need to provide encryption to all of these: network header, IP header, TCP IP header and data header. But whereas in the TCP level encryption, you need not protect IP header and the network header. You have to provide only the TCP header and data. But whereas if you at the application level, so you need to protect only the data. There is no need to protect the TCP IP and everything. So as you are going to the upper levels of your upper layers in OSA, so the data protected becomes less. Okay, the reason is you are providing link encryption. Okay, now let us see the traffic analysis. Traffic analysis is nothing but, as I said, monitoring or communication flows between parties. So monitoring how the data is communication between the parties is a traffic analysis. So it is at first it is identified in military and commercial spheres. So traffic analysis is usually done for when military people or military organizations are passing an secret information, the attackers tries to hack that information. Can also be used to create a covert channel. So covert channel, so any secret information if you want to gain, you can also do this traffic analysis. What the link encryption will do is that it obscures the header details. It will closes the header details. But overall traffic volumes in networks and at endpoints is still visible. So even you hide the header, the overall traffic volume. So you are only protecting the header. So you are just hiding the header. But the attacker can see some information is transferring and the length of the packet he is seeing. He is not able to find out what is the IP header, but he can observe some data is passing and what is the length of the packet. Everything he can see if you observe from overall viewpoint of traffic. So what the traffic, in those cases you have to do traffic padding. This, if you do the traffic padding, it will completely obscure the flow of data. So the attackers cannot even identify what is the length of the packet, how many packets are transmitting, so what is the size of the packet, everything he cannot find out by doing traffic padding. So traffic padding is nothing but it is a process of adding some unused bits to your original packets. So traffic padding is nothing but, so for example, if your packet size is 6 bits and you are transmitting equal 6 bits in a network, the attacker can easily identify that, so this much amount of data is transmitting between these parties. But if you make a continuous unused bits come to this, and he also identifies the frequency of messages passing. So at what frequent the messages are transmitting. So he will also attacker will also observe that. So to obscure even that, you have to continuously pass unused bits, and you have to mix that unused bits to your original data, so that the attacker will get confusion of what is going on in the traffic. That is called the traffic padding. So let's start the discussion. So now let us see the next topic in chapter 7, key distribution. So till now we have assumed that key is safely distributed between the two parties, sender and receiver. Just we are assuming that, but the key should be safely distributed between the sender and receiver. There is a procedure for distributing the key. So we will discuss about how the key is distributed in this topic. So in the symmetric encryption, both parties should share a common key. Both the parties use the same key, so that has to be distributed. So most of the systems are failed because of poor key distribution, not because of the poor environment of security, but because of you set up a good security environment, but you distributed your key in a safe way, in an unsafe way, so then your system will fail. So however, how protection be provided to your organization with security, so you should distribute your key safely, only then your system will be protected. So let us see how the key distribution is happened. So given there are two parties A and B, they can distribute the key in these different ways. So at the first, A can select key and physically deliver to B. So first A chooses the secret key between the two parties. For suppose A chooses the secret key and he physically delivers to, so he is physically delivered to B. They meet at one place and they will share it. Another technique is the third party can select and deliver key to A and B. They will choose one third party, trusted third party, and that the third party will distribute the key to both A and B. That is one way. If A and B have communicated previously, so if both the participants have communicated earlier regarding the distribution of the key, they can use the previous key for encrypting the present key. So they can use the previous key for encrypting the present key, so that they can distribute. Okay, and another one is A and B secure communication with a third party C, and C can relay key between A and B. So it is same as this one, third party. A and B have secure communication with the third party C. So they are having a third party C, they are having a secure communication with the A and B. A and B is having a secure communication with C, so that no other third party opponent will go into that access. So they are having a secure communication with party C, and C can relay key between A and B. C will send key between A and B. So these are the 4 ways you can distribute a secret key. Now let us see key hierarchy. So what is the hierarchy of keys? So basically we are having 2 types of keys. One is session key and the master key. Session key is just a temporary key. So use it for encryption of a data between users. So usually the private key which you are using for encryption is a session key. The private key which you are using in symmetric encryption is the session key. Means you shouldn't use that key for a longer time, because if you use that key for longer time, there is a chance of having an attack of that session key, and your messages will be stolen by attackers. So that's the reason why. So if you see, your email passwords are also to be changed. So some people say that you have to change your email passwords or any of your passwords frequently because for better security. So your password might be stolen by anyone. That's the reason why if you change that password frequently, so it will be even more secure. In the same way, you have to follow in the symmetric encryption. So that secret key has to be a session key that is usually only for particular session. Used for encryption of data between users. It is only used for one logical session and then it is discarded. Usually it is only used for one logical session. If it is a connection oriented, if it is used only for one logical session. If it is a connectionless, they will use it for a specified time and then they will discard it. And the master key. Master key is the key shared between the participant and the KDC, key distribution center. So there is a one trusted third party called the key distribution center. So they both share one key. That is the KDC and the participant will share one key. That is the master key. So they are used to encrypt session keys. So these master keys, the KDC will use this master key for encrypting the session key and send it to the participant. It is shared by user and the KDC. Now let us see how the key distribution is happened between the two participants A and B. Initially, it is done in 5 steps. Initially, the user A, the sender, sends a request to the KDC for having a session key, for getting session key. So in the request, he sends the identity of A, identity of B, and one nonce 1. Okay, he is sending the identity of A because KDC has to know from whom this message is from. So that's the reason why he sends his identity, and KDC also should know to whom it is. This session key is between whose pair. A wants to communicate with whom. That also the KDC has to know. Okay, that's the reason why he is sending the identity of B and nonce 1. This nonce 1 is used for acknowledgement purpose. So the A, when he receives this nonce 1 from KDC, he has an assurance that there is no modification in the middle. So in the network in the middle, there is no modification happened to the message. So that's the reason why nonce is used. So he sends identity of A, identity of B, and nonce 1 to KDC. And in reply, so KDC to the sender A, KDC encrypts the whole message with the KA. Here KA in the sense master key of A. So that is shared only between A and the KDC. So he encrypts with KA so that no other person can decrypt this message in the network. This KA is in the decryption key of KA is known only to the A, not even to the B. So okay, he encrypts with KA, and what he sends in the message is the session key, which is requested by A, and also his identity and receiver's identity and nonce. So he sends the same message which A sends to KDC to A. The reason is by looking at this message, so A assures that there is no modification happened. In addition to that, KDC also sends a message for B, which is encrypted with master key of B, so that only B can decrypt. But this message is sent to A, not directly, because A is requested, not the B. So by encrypting the message with B, even A cannot decrypt that message because that is the master key between A and B and the KDC. So encrypted with in the message, it sends the session key and the identity of A. So it is just like a ticket. So you can consider this as a ticket, the last written. So A will receive it and sends the same thing to the B. He doesn't do anything. A won't send the session key to B. So the session key is generated by KDC itself. He just sends a ticket to B. So by receiving this message, B finds the session key. B knows the session key, and it also finds out the session key is with the pair of A, because if KDC sends only the session key, P is in a confusion with whose pair this session key is, because B not only communicates with A, it also communicates with many other participants like C, D and E. If it gets only the session key, B is in a confusion that whose session key it is, whose pair of session key. Here you see, as I already told, the session key in symmetric encryption is used between pair of participants. For A and B, one pair of session key. And if B is communicating with C, B uses a different session key with B and C. So if B gets only the session key, B is in a confusion whose session key it is. So that's why by looking at the identity of A, B gets the knowledge that the session key is of the B's pair. So after receiving the session key, it returns a message to A, and it encrypts using the session key, because it gets session key, it uses the session key, and it sends a nonce to. So for authentication purpose, it sends a nonce to A, so that A confirms that B received the message. By receiving this message by A confirms that B received the session key. So A has a confirmation that B received the message, and A replies message to B, and it encrypts with A encrypts with the session key and generates a function to the nonce to, which is sent by B, and sends it to B. By receiving this message by B, it confirms that B confirms that A received the message. So, and there is no modification happened in the middle. Okay. So if you see, the first three steps are for key distribution, and the last two steps are for authentication. They are just only the authentication. So this message is from A, this message is from B. So those type of authentication is happened in the last two, and authentication and acknowledgement also. So this is how the key distribution when you are using a KDC. So this is the procedure of key distribution. Now let us see next concept, key distribution issues. So there are many issues with the key distribution. One is hierarchy of KDCs. If you see, if there are few number of participants for the KDC, so the KDC can maintain these participants easily, and they can distribute the session keys to these participants. But if the participants are increased gradually, there are many more participants, and only this single KDC cannot maintain all these participants, then it will be spread in different areas. The hierarchy of these KDCs are maintained. For example, if you see, take an example. So if a KDC is there in Vijayawada, so initially there might be 100 participants. If the participants are improved to 1 lakh, it cannot maintain. The KDC in Vijayawada cannot maintain. So what they will do, the participants are not only from Vijayawada, it is spreading all over the AP. Means the participants are in Gudivada, Visakhapatnam, like this different areas, participants are increasing. So if if it places a KDC in Visakhapatnam for the people who are in the Visakhapatnam, so then the KDCs will communicate with each other. When a person, for example, if the participant in Vijayawada KDC wants to send a message to the participant in Visakhapatnam, then what will do is the participant in Vijayawada will communicate first with the KDC with its KDC, with his KDC, and that KDC will communicate with the Visakhapatnam's KDC. So in this way, the hierarchy of KDCs are maintained in different places. Okay, instead of maintaining the single KDC and taking burden of all participants, the hierarchy of KDCs are maintained. And another issue is the session key. Session key lifetime is very less, only for one single connection when it comes to connection oriented, and when it comes to connectionless, only a specified period of time. So every time you need to generate different session keys for providing greater security. That is one issue. And you can also use the automatic key distribution, because manually it is not it will be very difficult for generating session keys and distributing to different parties. It is very difficult. So there is a system, automatic key distribution system. So this KDC, what this KDC will do is it takes requests from various participants and generates a random session key to each and every participant and sends this session key to the participants. This is done automatically, no human interaction is there, just like ATMs. So this is called the automatic key distribution, but the issue with this is you have to trust that system, whether that system is properly working or not. And you can also do decentralization key distribution. Decentralized in the sense, centralized means only one KDC is there and different other KDCs are communicating with that. But here decentralization means every KDC is having a control. Every KDC is having its own power. That is called the decentralization. So like this, in decentralization, the participant becomes a KDC. So what the participant will do is, the user here requests to the user B for generating the session key, and the user B generates the session key and sends it to user A. In this way the communication will be done. This is called decentralization of key distribution, and there are many controlling key usage techniques. So these are some of the issues in key distribution. And next concept is the random numbers. This is also very important concept in cryptography, because you use random numbers in so many places. In cryptography, in many of the cryptographic algorithms, you need a random number, because only when it is a random number, the opponents cannot guess which random number you had chosen. So that's why in cryptography, in most of the algorithms, in most of places, we use random numbers. So usually, what are the where exactly use random numbers means the nonces, which we discussed in the previous slide. Nonces in the sense, for getting acknowledgement, use nonces, and also for authentication protocols, use nonces to prevent replay attacks. So that in the first chapter we discussed about the replay attacks. The same message is replayed again and again. If you use the nonce, if you use the nonce, one random number, so when the person receives that message with the nonce, he gets assurance that this is not a replay of that message. So in this way, nonces are also useful in preventing the replay attacks, and these nonces are nothing but the random numbers. And session key in symmetric encryption, which we discussed just now. So these are also the random numbers. You have to use random numbers and generate a session key. And public key generation. So this is the next chapter's concept, public key encryption. In public key encryption, you have to generate public key. So while generating public key also you need a random numbers. And key stream for one-time pad. We discussed in the second chapter one-time pad cipher technique. So in that one-time pad cipher technique also you need to generate a random number for each and every message. You need a one-time pad. So it is just similar to one-time password OTP. So which nowadays it is very popular when you are doing online shopping. If you forget any password, they are sending a one-time password to your email ID. So that is generated automatically. The person will not prepare the random number and sending to it. It will automatically generated from their computer to your computer and sending to your computer. So just similar one is a one-time pad. So in this case also random numbers are very useful. So in all these cases the critical is that the values has to be statistically random. It is not like taking blindly some values in 1,000 and lakhs of values. The sequence of random numbers you are choosing should be statistically random. They should be mathematically proven. You have to use some function for generating. You cannot blindly choose random numbers. And those random values should also be uniformly distributed. For example, you are choosing a random numbers here, a sequence of random numbers that should be uniformly. For example, if there are 1 to 10 numbers, for example, you had chosen the number 5 for 100 times and number 3 for 10 times only. The person who is the attacker who is observing those things can easily identify one number is used for much time and another number is used for less time. So that observation the attacker can do. That's why you have to use all the numbers almost uniformly, not exact uniform. You have to use all the random numbers uniformly so that it creates confusion to the attacker. And also these random numbers, there should not be any relation between one number to another. If you place all these random numbers in one paper, so all random numbers should be independent. There should not be any relationship between one random number to another random number. So these are the things you have to follow when you are generating random numbers. And the values and these random numbers should also be unpredictable of future. So the future value you shouldn't remember, you shouldn't predict. It should be in a way you cannot predict the future value of a random number from the previous. For example, if you are preparing for a competitive exams in reasoning, they are given some series and you need to find the next number. If you are a good mathematician, if you have a good reasoning skills, you can say the next number by looking at the series. But the random numbers which are generated in cryptography, you cannot able to predict the next number in any way. So such complex random numbers you have to choose. And next concept, pseudo random number generators. So these random numbers are generated by this deterministic algorithmic techniques. You use some algorithmic techniques to create these random numbers. So although they are not truly random, they are not exactly random, but they have to pass many randomness. They have to pass many tests of randomness. Such a type of numbers are the pseudo random number generators. They are created by pseudo random number generators. There are some machines like pseudo random number generators. These generators will create the random numbers. And next one is the linear congruent generator. So you are having a one formula which generates random numbers iteratively. So that formula is xn plus 1 is equal to a into xn plus c mod m. So if you substitute the values of x, n, a, c and m, you will get various random numbers. So by substituting those values in that formula, you will get various random numbers. That is a linear congruent generation. So, but the thing is, you need to generate full period, in the sense the values which you had chosen for substitution should be very complex and a very large number. You shouldn't choose simple numbers. If you choose simple number, you will get only few random numbers like 10 or 20. But if you choose the large numbers of substitution, you will get more number of random numbers. You need a full period of numbers, and the generated sequence should appear random. So the sequence, the generated values should be random. There should not be any relation between them. Efficient implementation with 32-bit arithmetic. If you use the 32-bit arithmetic, you can get an efficient values of randoms. So you should also note that attacker can reconstruct the sequence. So the attacker, if the attacker is very good knowledge, is having a good knowledge, he can reconstruct the sequence and he can find out the randomness. So that's why you need to be very careful while choosing the values. And it is also having the possibility of making this harder. You can make this even more harder by choosing different values. So this is about the random numbers. So we discussed pseudo random number generators and linear congruent generators. Now let us see the summary. So in this chapter we discussed about the placement of symmetric encryption, where you have to place encryption. We are having two approaches, link encryption and end-to-end encryption, and we also discussed the key distribution, how the symmetric keys or the session key is distributed using the KDC, and we also discussed about the trusted third-party KDCs, and finally we discussed random number generators. So with this, the 7th chapter is over. Thanks for watching this video.